Hello students, today I am going to explain Bohr's model of atom. Okay, I have given this topic in your WhatsApp, okay, that photo and all, so you can check from there. I am just going to explain a little bit from here. Bohr's model of atom. Okay, here we have seen before last video also drawbacks of Rutherford, means defects of Rutherford model. 2-3 defects are there, so Rutherford's. Then later on Niels Bohr in 1913, he in 1913, okay, Niels Bohr in 1913, he has studied Rutherford's model of atom, okay, and after this he has given this about these defects he has suggested, and some another model name is given Bohr's model of atom. He rectified these defects, and he has given two postulates, okay. From there we corrected little bit Rutherford's model of atom. He said that Rutherford explained for macroscopic, okay, that theory basically macroscopic. Macro means this classical mechanics. We are dealing with stone and all this thing in Newton's laws of motion. We have seen this is classical mechanics. So for electron is very small. Electron is very small, okay, like a dot. Electron is very small like a dot, okay. So electrons cannot be explained as macroscopic, like macroscopic objects. It should be explained like microscopic. Micro means very small, okay, micro. So in microscopic, this he given this idea that when electrons revolving around the nucleus, okay, suppose electrons revolving around the nucleus, suppose electrons revolving around the nucleus, okay, so it will not electrons, it will not radiate energy all the times, okay. In certain time it will radiate energy according to Bohr, he has seen, okay. So electrons is very small, so we are dealing with here microscopic, like a microscopic object. Microscopic, micro means small, micro means very small object. So Rutherford saying that it will emit energy all the time, but it will not according to Bohr. He has given another theory for this, basics on Rutherford, but he has given another theory. What is the theory? See now. What are the two postulates? One postulate is this one, okay. One postulate is which one? See this one, given the diagram, okay. So here r is the radius from the nucleus to the circumference. This is the radius, means this is the distance from the nucleus to the electron. M is the mass of the electron, b is the velocity of the electron. So what he has given, that he is saying that the electron revolving around the nucleus, nucleus positively charged, the electrons revolving around the nucleus, it will revolve around the nucleus in certain circular orbit, okay, certain circular orbit, and that time they do not radiate energy. When it will revolve around the nucleus, so it will not radiate energy cannot emit that time, okay, energy will not emit that time, okay. When it will radiate energy, it will not radiate energy. When electrons revolving in certain circular orbits, then it will not radiate energy, it will not radiate, only revolve. So this stage is called what? Stationary orbit or stationary states. This is called what? Stationary, that time stationary orbits or stationary states, okay, stationary orbits or stationary states, okay. Formula is for this. What is the formula? Look for this formula, okay. This formula is given nh by 2 pi, nh by 2 pi. So m, I have just explained before, m is the mass of the electron, b is the velocity of the electron, r is the radius of the stationary orbit, like this, okay. And n equal to given number 1 2 3, that is a whole number integer, and h equal to Planck's constant, h equal to Planck's constant. Planck's constant is what? 6.62 into 10 to the minus 34 joule second. You know this is a constant value. Okay. So what is the formula he has given? Board has given the formula MBR equal to NH by 2 pi. MBR equal to NH by 2 pi. From here we can find out R also, V also. We can find out from there. Okay. And what is R? Suppose we are going to find, so radius R equal to NH by 2 pi MB, cross multiplication that time. Okay, this is equation number 2, this is equation number 1 formula. Okay, this is postulate 1. So from here we can find radius also, velocity also. We will see one by one later on. This is the postulate number 1. What is the postulate 1? It is given, so I will just explain with this diagram. Small diagram is there and one formula is there. What is this? Okay, here is only mainly stationary orbit, he explained. And stationary 2, postulate 2, stationary postulate 2 is what? Sorry, postulate 2 is what? Stationary orbit, again we will see, but it is a little bit difference is there. Okay, here postulate 2, what it is saying, when electron jump from one orbit to another orbit. Suppose here, okay, suppose here positive charge nucleus, electron is here, N1, suppose electron revolving around the nucleus, another is there N2. Okay, so when according to Bohr, he is saying that if electron jump from outer orbit to inner orbit, that time it will radiate energy. Okay, not when it will revolve around the nucleus, it will not radiate energy. When electron jump from one orbit, outer orbit to inner orbit, then it will radiate energy. Then how to do? See, like this. Okay, it will radiate energy. So it will give like this frequency and all, HF. How much energy is radiate? We will give this wavy line and we will show. Suppose this is the diagram HF. Okay, so H equal to Planck's constant, F equal to frequency, N2 equal to orbit, one orbit. Suppose N1 equal to another orbit, two orbits we are taking, nucleus are positively charged. Okay, then this is electrons jumping from outer orbit to inner orbit, then it will radiate energy. Same, if we suppose electrons leave to inner to the outer, then also it will require same amount of energy. Okay, now what energy and all we will see now. Suppose here energy, suppose in outer orbit energy is E2. Suppose energy is E2. Suppose here energy is E2. And inner orbit N1, inner orbit, suppose energy, we are writing energy is E1. Okay, energy is E1. One is E2, another is E1. Then what will happen? What is the energy to radiate? Difference of these two. So difference is what? E2 minus E1 is equal to HF. E2 minus E1 equal to HF. Okay, E2 minus E1 equal to HF. So this type mass of energy it will radiate. Okay, this formula we have given also before from Planck's constant. We are taking this formula. Planck's constant has given this formula is what? Energy is equal to HF. We have done before. E equal to HF. Before also we have done this one. E equal to HF. From there, and here is energy. What is the energy? How much energy is required? How much energy is radiate, release? So U2 minus E1 equal to HF. Okay, so this is the from Planck's constant. We have taken the formula. So this is in postulate 2. The Bohr has given. Okay, what is the energy? How much energy is radiate? If suppose this electron jumping from jumping from outer to inner, okay, this is suppose it will leave to inner to outer. Suppose electron will go from inner orbit to outer orbit, then also same amount of energy this electron is required. Okay, this is in postulate 2. What is the idea Bohr has given? So these mainly two postulates is given in Bohr's model of atom. So you can write this one you can write in a little bit, you can make it short also a little bit. This is the main point, this is the main point, and formula you have to write, diagram you have to give, okay, diagram you have to draw, and little bit you can explain. Okay, another point is there. Okay, another thing is there, the angular momentum does not have continuous range of values, that is, it is quantized. What is quantized, it may ask, so this you can write here this line. Okay, quantization. Okay, so okay, this is quantized, you can write, but up to this much also you can give the formula. Okay, and postulate 2 you have to explain little bit, italic ones, and diagram and formula is very important. Formula you have to explain. Okay, second formula is in postulate 2, E2 minus N equal to HF. I have just now I have explained. Okay, so this is all about your Bohr's model of atom to postulates. Okay, and why Bohr has given new model, and because Rutherford has some defects, so he has given his own theory, and he rectified these defects also. So that's why Bohr's model is very important, and two postulates we have discussed today. Okay, so if not understand, then you ask me. If any point want to be clear, then you can ask me. Okay, next we will do Bohr's theory of hydrogen atom. We have to do this, is a little bit numericals are there. I mean, numericals means numericals based on these formulas also there are many, and we can check, and deduction is there, so we'll do later on. Okay, next class, not today. Okay, then bye students.